top of page 391, they're going over the material that we started with. Basically, they're showing that when you graph a linear inequality, you need to show which section of the coordinate plane has the solutions in it. The graph of this area is called a half plane, and it is bounded by a line. Everything on this side is a solution, everything on this side is not a solution. And they go through and explain the whole dashed and solid line thing, which you already know. And I think we're ready for problem 2. They're going over these steps that you already know. If you're trying to graph an inequality in 2 variables, the process is exactly the same as what you did graphing 1 variable at the very beginning of the lesson. So, given y is greater than x minus 2, first graph a boundary line for y is equal to x minus 2. This is a greater than, not a greater than or equal to. So you need to use a dashed line, such as this one. There we go. Such as this one, to show the boundary. Then you have to figure out which side of the graph you're going to color in. So you can almost always use it, just use the origin. Is 0 greater than negative 2? Yes, it is. So shade in the side of your boundary line that has the origin in it. You got it, number 2. So, problem 4, here we go with our practical application of the math you have just used. An interior decorator is remodeling a kitchen. We are focusing on this wall. How much of the wall is going to be tiled, and how much of the wall is going to be papered? The owners can spend $420 or less, which means that the owners should not be remodeling their kitchen. But anyway, you need to write a linear inequality and graph the solutions, and they want specifically 3 possible prices. So that means after you've come up with your inequality and graphed it, they want you to find any 3 points that are within the solution of this inequality. Alright, it's a little bit hard to read those numbers. So the tiled area is 12 feet squared. The papered area is 24 feet squared. And let's take a look at the variables we have. X is going to be the cost per square foot of paper. Y is going to be the cost per square foot of tiles. Write an inequality. 24x, y 20. Why did they use the number, the coefficient 24 in front of x? Well, because from up here we have 24 square feet that need to be papered. 12y. Where did the number 12 come from? We have 12 square feet that need to be tiled. So the number of square feet that you need to paper plus the number of square feet that you need to tile, that total needs to be less than or equal to $420, which is the amount of money that they have to spend. So from there you simplify, solve it for y, because then it's easier to graph. You've got a y-intercept and you've got a slope. Inequality symbol is less than or equal to, so you know that the boundary line is solid. They pointed out up above on page 392 that when our inequality is y is less than or equal to, you can shade to the left. If it is greater than or equal to, you can shade to the right. I like to just check 0, 0 because then I don't get too twisted up wondering, well, but what if the slope is this way and which is the left? I just check. At any rate, on this particular graph, this is the side that's going to be shaded. Y-intercept, using the slope, they've drawn the line, colored it in, but this is not your final answer because remember they want 3 specific points. So you can take any 3 points. You can take 5, 5, you can take 5, 15, whatever you like. But then you have to remember to put it in terms of this problem. 3 possible prices per square foot are $5 and $25, $5 and $15, and $10 and $10. The last piece of advice I want you to focus on over here, which inequality symbol should you use? Make sure you read the problem carefully. They say $420 or less means that $420 is included, so it needs to be a less than or equal to sign. Got it. Number 4, very similar problem. You are trying to spend no more than $12 on nuts. Here are the prices of the peanuts and the cashews that you're trying to buy. And they don't want a graph or an equation. They want 3 possible combinations of peanuts and cashews that you can buy. So you do not have to graph it, but you do have to come up with an equation to figure this out. So here's your setup. I chose x and y for my variables. If you chose something else, that's not too horrible. The reason I chose x and y is because that just made it very simple for me to turn this into plain old slope-intercept form. You should have ended up with a linear inequality that looked a little bit like this. And I thought about that, and I decided, it'll just be easier to solve this problem if I graph it, because we have our y-intercept, and we have our negative slope. So we're going to go this way, down 1 over 2, Three points is one more than I need. Grab my ruler. You'll notice this is only a quadrant 1 graph because we can't deal with negative money or amounts of peanuts. And which side of this graph are we coloring in? That's right, over here. So anything that's in this nice purple triangle works. So I have 2 problems with problem 5. First of all, I complain every time they bring up a multiple choice one. Second of all, the got it is a different type of problem than problem 5. So we're just going to talk through them both quickly because this video is long enough. They want to know which inequality matches up with this graph. So the first thing you're going to look at is, oh look, solid line. So you're going to eliminate B and D. Sorry, you're going to eliminate D because that doesn't have, it's not an or equal to. Then you're just going to test out a couple of points and figure out your answer. The origin 0, 0 is included in the solution, so that needs to be taken into consideration. And that's how you would tackle that problem. I'm not sure that you're ever going to see one. Got it, number 5, at least for me. This is the other way. You are writing an inequality from a graph. The boundary line is dashed and has a slope 1/3 and a y-intercept -2. The area above the line is shaded. What inequality should you write? Well, it's going to be in slope-intercept form. It's going to be y something 1/3 x minus 2. The area above the line is shaded, so that tells you that y is greater than 1/3 x minus 2. And I don't want to spend any more time worrying about that because this is not a big deal. I'd rather you understand the other material.